All right, so right-angled trigonometry. Right-angled trigonometry is one of those concepts that we're going to look at a lot in here, where we have to understand, okay, what is a triangle? How does it help me in calculus? And what do I use it to solve for? So we use right triangle trig for many applications. One of those applications is being able to take a triangle, draw a triangle from 2 points on that triangle, and understand, okay, what quadrant is that triangle located in, and then what are all the other different trig functions that go along with it. So maybe we're given a point, and we'll say that we are given a point that is both positive and negative. So maybe I want to look at the point -1, positive 3. Well, let me go full screen. Sorry about that. So if I look at the point -1, positive 3, I know that because the x value is negative, that I am now in quadrant 2 or 3. The y value is positive, so that puts me in quadrant 2. So if I were to draw this as a triangle in the planar field, I know that this triangle is going to live at -1, positive 3. So if it lives over there, then I know that certain trig functions are going to be positive or negative given that. So in quadrant 1, all of the trig functions are positive. In quadrant 2, some of the trig functions are positive, and those are the sines. In quadrant 3, the tangent is positive, and in quadrant 4, the cosine is positive. So all students take calc is how you can help yourself remember the order of positivity the quadrants go. So in quadrant 1, all of those will be positive, and then 2, the sine, as well as its reciprocal identity friend, will be positive. So we're looking for the 6 trig values that go along with this. So we know that sine and cosine are reciprocals of each other. Cosine and secant are reciprocals of each other. And tangent and cotangent are reciprocals of each other. So after I have my points, I need to use Pythagorean theorem to find the missing side. So the length of the side of the triangle here is -1. The length of the side up is 3. Now we know when we talk about length that -1 is going to become positive. But this is like my a squared, b squared, c squared. So we're going to plug in. So you have -1 squared plus 3 squared equals that missing side, which is the hypotenuse. So I get 1 plus 9 equals c squared. So c is equal to the square root of 10. The sine is always going to be the x length. So in this case, we know that the length of x goes with The cosine, the length and height of sine is going to go with the y values. So we have that nice mnemonic device. So, when we are talking about a right triangle on the coordinate plane, the theta is always the angle made between the triangle and the origin. So theta is over here in this corner. Let me see if I can move and zoom. Okay, if theta is over here in this corner, then what that means is that my opposite is here, my adjacent is down here, and my hypotenuse is always across from the 90 degree. So sine is opposite over hypotenuse. So it's going to be 3 over h, where h is square root 10. Oops. Cosine is adjacent over hypotenuse, so it would be -1 over root 10. And tangent is sine over cosine, so -3. The reciprocal functions are simply taking those fractions or whole numbers and flipping them. So sine becomes root 10 over 3. Secant becomes negative root 10. And cotangent becomes negative 1/3. I was thinking perpendicular, which is opposite reciprocal. Okay, so again, we have placed the figure using its terminal side. So that point P is what we call a terminal side. Now we've used Pythagorean theorem to get the missing length. And then we applied SOHCAHTOA to fill in our 6 trigonometric functions. Good? It's all starting to like slowly come back. I'm kind of like, all right, I remember doing that. So this also, the all students take calc kind of goes into finding where, possibly given information lies. So we might be told that the sine of theta is greater than 0. What that tells me then is that sine is positive. If the sine is positive, then the only quadrant this could live in is 1 or 2. If sine is positive, I cannot live in quadrants 3 or 4. What I need to know whether it's in 1 or 2 then is something about one of the other trig functions besides cosecant. So if I was told the tangent is negative, then I would live in quadrant 2. If the tangent were positive, then you would live in quadrant 1. So you always want to figure out the first, use it to help you eliminate quadrants, and then look at the second piece of information. Okay, let's look over at letter R then in the packet. So, yes. Sure. I just forget if cosecant. Yep. Yep. So if you go and look at like this line up there, I tried to write the partners across from each other. So like sine is partnered with cosecant, cosine is partnered with secant. So if cosine's negative, secant's negative. If secant's negative, then cosine is negative. And then same with tangent and cotangent. So these little guys here are friends in terms of matching their signs. So we have three special triangles. We have a 30, 60, 90, a 45, 45, 90, and a variation of the 30, 60, 90 where we flip it and we make it a 60, 30, 90. These three triangles continuously pop up in calculus as well as in trigonometry because they are part of the unit circle. So if you think about the unit circle repeats itself over all four quadrants. But in that first quadrant, we always look at our three main angles. So we have our 30, 45, and 60. And then we go all the way up to the top, and that's our 90. We know that 30 degrees also correlates to pi 6. 45 degrees is pi fourths. 60 is pi thirds. And 90 is pi halves. Each of these right triangles correlate to a particular value on the unit circle for sine and cosine. But if you go back to the example we were just talking about, these values actually also relate to the right triangle. So we know down here when the angle is 0, this correlates to the point 1, 0. Then, as we are moving up the unit circle, the x value is actually moving to the left and getting smaller, while the y value is rising and getting larger. So these points are changing their values with respect to the coordinate plane. So as you're going up, the y's are going up. As you're going left, the x's are going down. Everybody has trouble remembering the 30s and the 60s, or pi 6 and pi thirds. I think we always have a tendency to confuse them. Pi fourths, everybody gets, so I was like, yeah, root 2 over 2. Well, when you're setting up the other values, so I talked about that the y values are going up. So as you count, you're going up. So it goes 1, 2, 3. So as y goes up, it goes 1, 2, 3 on the outside for the y value. All of them are always over 2. The x's, I said, are getting smaller to the left. So it goes 3, 2, 1. And then at the top, we're at 90. So again, the x value is getting smaller, right? It's root 3 over 2, root 2 over 2, root 1 over 2, all the way to 0. And the y value got larger and gets all the way to 1. Each of these parts of the unit circle are based off of their triangle friends. So a 30-degree angle and a right triangle makes the top angle 90. So remember, I always said that we talk about this angle down here as our main angle for the triangle. So that means across from 30 is opposite. Here's my adjacent. Here's my hypotenuse. If you take the 30, 60, 90 triangle right from that unit circle here, that means the height of the triangle, or the opposite, is 1/2. And the adjacent, or the x length, on the bottom is √3/2. So to find the hypotenuse, we would hope then that the hypotenuse is the same as what other value? Going along with what we're saying, the hypotenuse should be the same as what other value? Any thoughts? Okay, let's see what the hypotenuse is the same as then. So we'll take √3/2 squared plus 1/2 squared equals the hypotenuse squared. So a squaring of a square root cancel, you get 3/4. 1/2 squared is 1/4. So you get h squared. So 3/4 plus 1/4 is 1. Does it make sense that the length of the hypotenuse is 1? What type of triangle is this? What do we call this circle right here? Right? The unit circle. Unit or uni means what? 1. The unit circle, by definition, calling it the unit circle, has a radius always of, thank you, 1. So again, this is the unit circle. It has a radius of 1. The hypotenuse of that 30, 60, 90 triangle better be 1. If you go back to SOHCAHTOA, right, tangent is opposite over hypotenuse. So again, you're going to get that 1 over square root 3. Let's look at a problem from page R. See if it kind of helps us a little bit more. I think page R is one of the ones that we're going to spend a little more time on. I think this is the topic Miss Lacey, I think, said she emailed us on, and maybe we didn't learn it. Okay? Or that's topic S, which is my favorite. We're actually going to skip S in the packet because I'm going to teach you it next week. So I got the email that we didn't do it after I had already made them. So you guys can actually put S, don't put a big X because we're going to use the page later. But S is something we're going to look at next week a little bit more in detail because I'm finding out we never actually got to see S in action. So letter R is basically taking what we just talked about with the quadrant in the circle. If you look in the packet I gave you with helpful hints, it also gives it to you in chart form. So I gave it to you in triangle and coordinate form. The packet I gave you gives it to you in chart form. So what I want to do is look at our number 1, just to kind of refresh you on this concept. So it says evaluate each of the following without looking at a chart. So you're trying to really memorize what those values are, but we haven't quite got there yet this year. So we have sine squared 120 plus cosine squared 120. So 120 degrees is in what quadrant? Okay, let's refresh that, right? So here's 0. At the top is what degree? Yeah. Over here on this side is 180, and down at the bottom is perfect. So that means that 120 lives over here in quadrant 2. If it lives in quadrant 2, then sine is positive and cosine is negative. And then if it tells you to evaluate without looking at a chart, what we're trying to do is figure out, okay, what angle does that correlate to in quadrant 1? So you go from 180 to the 120, and we would realize that this coordinates to a 60-degree angle. The square on a trig function can be rewritten outside. So it's kind of the same as saying the sine of 120, finding that first and then squaring it, finding the cosine of 120 and then squaring it. We know the sine of 120 correlates to the sine of 60, and that the sine of 60 from the previous page is root 3 over 2. We're in quadrant 2, so sine is positive, and we're going to square it. The cosine of 120 is a half. It would, however, be negative, but we know that any negative number squared ends up being positive. Perfect. Sine squared plus cosine squared. If you don't know your angle, what's the rule about sine squared x plus cosine squared x? What's that equal? Ooh, this is a trigonometric identity. Sine squared plus cosine squared equals. There's a hint. It's a number. Oh. Yeah. So if I have the sine of 120 plus the cosine of 120, that 120 is kind of like an x. So my hope and goal is that this equals 1. Because again, this is the unit circle values. So you have root 3 over 2, which is again 3 over 4. 1/2 becomes 1/4, and we can see, in fact, it is 1, and that this correlates to that trig identity. This is why you're not doing letter S. Letter S is all trig identities. Please tell me, maybe once I wrote that, recall sine squared plus cosine squared equals 1? Tim's looking like, I don't know what that is at all.
I don't remember that at all.
Oh no. How about any with like secant? Do you know what secant's friend was with the squared stuff? Okay. We're going to learn letter S. I really enjoy that. It's been a while since I've had it. So if you turn actually in the packets I gave you of non-problems and you look at letter S, that's kind of what letter S is talking about. If you look at the top of that page, right under the fundamental trig identities, that very first one there is sine squared plus cosine squared equals 1. And then I said there's one that mixes tangent with secant, and one that mixes cotangent and cosecant. So we already kind of talked about the reciprocal identities, and we talked about the fact that cosecant is partnered with sine, and it's 1 over sine, or the reciprocal of sine. And then we have that secant is paired with 1 over cosine. And cotangent is paired with 1 over tangent. But it's important to recall that the tangent of x is sine over cosine. So if cotangent is 1 over tangent, then it's really kind of like 1 over sine over cosine. But we know that fractions and fractions are a no-no. So we have to get rid of our fraction and our fraction, and we get cosine x over sine x. The identities that come from those are the sine squared plus cosine squared equals 1. And then 1 plus tan squared equals secant squared. And again, we'll save looking at those identities for next week because that's a whole lesson in itself. And I want to break it down for you with the proofs and how it works. Actually, maybe I'll do that tomorrow. I can do that. All right. The last page is using trigonometric equations to find solutions. So this is essentially saying, okay, all factoring problems get set equal to 0 to find the solutions for a quadratic. So if I gave you something like x squared plus 2x equals 6, we know that to solve a quadratic, we set it equal to 0. That's called standard form. If it's factorable, then we would solve it using our factors. So are there factors of 6 that sum to 2? No. So it's not factorable. So when something's not factorable, we use the quadratic formula. So you would set this up and you'd say, okay, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative times negative gives you positive. 24 plus 4 is 28. All over 2. So what that means is that this quadratic has 2 real solutions. And the first real solution is negative 2 plus square root 28 over 2. And the second is negative 2 minus square root 28 over 2. So the same can be true or said of trig functions. They also have solutions or identities that give them those solutions. So if you look at something like number 1 in the review with solutions, we have x cosine x equals 3 cosine x. I feel like the immediate reaction is to divide both sides by cosine. But if you go back to the previous problem, we didn't divide those sides by cosine, or we didn't divide those sides by 6, we subtracted the 6. So you want to be cautious and make sure that we don't break our laws of algebra. If we subtract that, and get it set equal to 0, if I took away the cosine and I called cosine x a, so that everywhere you have a cosine x, you have the letter a, you would have x a minus 3a. If I asked you to get that in factored form, what do you do to that letter a? It acts as a GCF. So you bring the a out, leaving with x minus 3. Well, if you plug a back in as cosine x, this is the factored form. So now we can split our problem and say, okay, the cosine of x equals 0, or x minus 3 equals 0, because of the zero product property. The zero product property said if two things are being multiplied together, then the first thing multiplied has to equal 0, or the second thing multiplied has to equal 0, or both. When does the cosine of x equal 0? Well, let's go back to our unit circle. The cosine of x is at 0, not at 30, 45, 60, but at 90. So cosine of x is 0 at 90, or pi halves. So when x is pi halves, cosine is 0. And then at the opposite angle to that, or down below, which is 3 pi halves. What value of x minus 3 makes it 0? 3. The trig functions act like any other variable. Trig functions act like any other variable. You may have to look at page S on page T just for some of the solving ones, and I can kind of like go back and look for you. You may need to use sine squared x plus cosine squared x equals 1. So today, I want you to work on any of the letters in the packet you're not done with, kind of up through letter R. And then for tomorrow, we're going to do half of the pages from half the problems from S and half from T, but those will not be due. So tomorrow, the due packets are going to be A through R now. S and T will be due after the weekend break. So due tomorrow is A through R. S and T will learn tomorrow, and they'll be due after the break. because I wasn't sure what part of the trigonometric identities and stuff you weren't quite yet gotten to.